Hello and welcome to today's webinar hosted by Global Mining Review on behalf of Emerson. Thank you all for joining us. My name is Will Owen and I am the editor of Global Mining Review. Today's presentation is titled Unlocking a New Era of Mining with Edge and will be given by Tishan Naidu and Dieter Gebert. Both Tishan and Dieter work on Emerson's machine automation solutions portfolio, Dieter as a solutions architect and Tishan as a marketing leader responsible for the heavy and hybrid industries market. At the end of the presentation, we'll be opening up the floor to answer some questions from the audience. So I'd like to invite you to submit your questions throughout the course of the webinar and during the Q&A itself. For those of you joining us on mobile devices, you can access the question box by simply tapping the icon at the bottom of your screen. And for those of you using a desktop or laptop, just click the orange arrow on the right of your screen to open up the user interface and reveal the question box. We'll do our best to get through as many questions as possible in the time we have available today, but if we can't cover them all, we will make sure they are passed on to the team at Emerson and they will be able to get back to you at a later date. Before we begin the presentation, a quick reminder that everyone who is registered to attend this webinar will be emailed a full recording after today's session. Now, without further delay, over to Tishan and Dieter for the presentation.
Good morning, good afternoon, everyone. My name is Tishan Naidu, as Will has explained. And for today's discussion, I think what we really want to center around is the changing landscape of mining and understanding how edge solutions can unlock a new era for the mining industry. I think mining today, we understand, has been really pivotal to human development. And as we transition into a new era around renewable energy and greener technology, we know that mining's role here cannot be overstated. It is ironic as well that the industry that isn't perceived as highly green and sustainable will now be crucial to that renewables transition. But with that, the industry itself is facing a number of evolving challenges. I think you will agree it's a really complex landscape today, and it requires a high degree of flexibility to cope with today's challenges, and then great foresight and investment to face the future challenges that are on the horizon. And if you pull up any annual report from a mining company today, you will see that the industry is really focused on environmental, social, and governance issues and balancing the need of the various stakeholders. So miners are really trying to do more to integrate ESG into their corporate strategies, decision-making, and meeting the needs of the various stakeholders. Some of the pressing issues I see today at this point in time are decarbonization, plotting out a viable roadmap for digital and innovation. How do we attract and retain talent in this industry? And then how do we manage productivity and costs? And I've outlined these specifically because automation has a huge role to play in overcoming these challenges. So from a decarbonization perspective, the industry has to continue to monitor operations and assets and navigate to a path of net zero. From a digital and innovation perspective, the industry is constantly going through transformation. And they understand that this is going to be key to unlocking incremental productivity gains. So things like aggregating and analyzing data across this value chain will be vital to optimize decision making. And we've had the added challenge of COVID-19, which was a real big test for the industry to adapt, especially when it came to managing on-site personnel during the pandemic. So this is again where miners that were already using extensive automation and remote operation centers have fared better during the pandemic. And not surprisingly, many companies now are looking to the same direction to invest in these areas and to be more resilient. Furthermore, the industry faces a challenge to attract and retain talent. We know that a large percentage of the workforce is slowly retiring. Again, this isn't an industry that's seen as attractive to work in, and then you have the added complexity that new mines are becoming even more remote. Additionally, there's also the challenge of a large digital literacy gap that has to be bridged in order to make the workforce ready for the future. Beyond this as well, I think the industry has always been dealing with volatile demands. It's a very cyclical business, and we've seen more and more challenges over the last few years. And with that, rising production costs, which are proving even more challenging for miners. So this is again where aspects like full production visibility, asset performance management is becoming more crucial in optimizing and controlling costs. Now, without a doubt, automation is going to play a huge role in tackling these challenges and contributing to a more sustainable business model for miners. Again, what's really needed is agility and evolution. That's going to help mining companies to stay competitive in this space. At a high level, again, we understand what needs to be tackled. Reducing downtime, harnessing real-time data to get visibility into operations, and then making smarter data-driven decisions to drive optimization across the entire value chain. At this point, again, we understand that automation is needed, but deciding on the most efficient, risk-free way to automate and how do you future-proof that automation investment are really the questions that every mining company needs to be asking at this point in time. So companies are already on a digital journey. They understand digital transformation is crucial for them to survive and be competitive in this space. But we know historically mining companies have been technology innovators and leaders in some areas, and in many other areas, they've been followers and late adopters. This is really moderated by risk and managerial conservatism, and sometimes just the sheer complexity and the scale of the operation becomes an obstacle to implementing wide-scale digital innovation. But as we look at that digital transformation journey and the spectrum that it is, we know that it typically starts with islands of automation, which is really characteristic of disparate and remote assets to a more connected state. I would say that some of the mining companies that have gone on a more extensive digital transformation journey and have adopted autonomous operations are most likely sitting somewhere between enhanced connectivity and insight-driven operations. But beyond this, we also understand that this digital transformation comes at a huge cost, and it requires a huge shift in operation culture. So a lot of this is also underpinned by this concept of big data. Now, big data itself is a problem when companies try to tackle it all at once. What happens is that any company can spend months or years planning, and a large amount of money goes into these projects that most of the time end in frustration. But there's a better approach that starts with little data, so known problems with defined parameters, and this focuses the field of view to a specific asset, reduces complexity, and then simplifies the search for a solution. So in most industries, this means starting at the machine or a piece of the process. And this is where the concept of edge computing and edge-enabled architectures plays a crucial role in this journey. And let's explore that concept further and what it could mean for the mining space. Now, this little data that we spoke about is really produced from edge computing. The edge brings computing and data storage as close to the data source as possible, with the expectation of improving response time and saving bandwidth. This computation element allows for the analysis and generates insight that can be supplied to the right personnel for fast, informed action. So with one problem solved, then you can move on to the next and the next. And this means running fewer processes in the cloud and enterprise system. And this is where edge computing really makes IIoT a reality for a plant today. It's easy to integrate without having to start over and facilitates digital transformation one affordable step at a time. Now, there are different edge components, and the approaches to handling little data can be varied, and they have increasing capabilities. It really starts with a single wireless or other wireless measurement devices that transmit data to other edge solutions. So the next evolution up there would be an edge gateway, which is the most basic IIoT enabling device. These connect with intelligent source devices like PLCs, smart sensors, and then forward data onto a high-level system, both on-premise or off-premise for further analysis. They aren't used for direct control, but they can integrate control system data and non-control system data, so users have one view of the entire operation. The next level up would be the edge computer, which adds the ability to generate new data, and this would be typically an industrial PC that would have the ability to collect and analyze data locally. Now, again, both the edge gateway and the industrial PC would still need to be paired with a PLC. Then lastly, we have the edge PLC controller. And this is the most capable and the most interesting edge computing option for implementing IIoT. It's based on a multi-core processor hardware and uses a real-time hardware virtualization hypervisor to create two independent operating systems, one to run the traditional deterministic control of the PLC and one to run the data computation aspect. And this really integrates the edge processing component into a single system.
Hi everyone, Dieter here. So having a look at this, our PACSystems portfolio of industrial automation controllers include PLC, edge devices, and edge controllers. Our next generation control solution help optimize industrial process safety securely, reliably, because of these following factors. So accessibility, security, reliability, ruggedness, and then obviously incorporating our edge controls. And here's what it means to have the power of the edge control. We've set a new standard here, bringing something new to the market, bringing process down to a machine layer. And as Tashinran said, having both a real-time control system as well as the edge controller, but it does this in a safe and secure way. And it connects with the real-time deterministic control system. As actions are happening in your mine site, you can directly analyze that data and turn that into insights right at the edge. We call this technology that makes this possible hypervisor technology, and basically combines the logic and the application side in one controller. So we hypervise a COM Express module, and that just gives us the most flexibility in our rugged component, the CPL410. Other companies tend to do this in two controllers or two devices / two processors. That just adds a lot of complexity and cost and possible failure points. Yeah, and with one control, we have half of the hardware running the logic engine and the other half running your application. And you can think of applications like Node-RED flows or possible Python scripts, whatever you may come up of, or your own Docker container that you've already developed and you're trying to deploy that in our environment, that's possible. And to do this reliable way, if something does go wrong, the engine always stays up and running on your deterministic control system. So your process keeps on going no matter what happens on the application side. And that application side can process data. It can run local dashboards and visualization to generate some insights. If you're not quite there yet in your whole digital transformation journey, just use it as a black box recorder or a data logger, right? And then when you are ready, you've got the data on hand and you're ready to go. And you can connect right away from anywhere. It's all based on open source technology. The PACEdge is our industrial edge platform that delivers a scalable and open connectivity, making data and analytics accessible from machine level to enterprise. The PACEdge platform simplifies application development by bringing together today's leading, again, as I mentioned, open source tools in a flexible, integrated, and secure platform for utilizing machine data and analytics. Emerson's enhanced industrial edge portfolio offers an IoT-ready solution for our mining customers and OEMs.
So with that in mind, and based on that little data approach, what we offer as Emerson is a very pragmatic approach to future-proofing your automation for the next step in this digital transformation. Firstly, what we're saying is select the right architecture and pair that with high availability to ensure that you have optimal uptime on your equipment and your site. Then configuration is made easy with the single tool chain concept, which not only makes programming easier, but the subsequent maintenance of your entire site much easier. And then the customer has the freedom to quickly deploy IoT optimization with PACEdge. And this allows you to achieve incremental value quickly on smaller optimization exercises and then scale this at the pace that you want to go at. So like I said, because we have quite an extensive portfolio of edge technology and devices, you can pair this with your current infrastructure. So based on the portfolio and what you have currently on site, this could entail embedding industrial PCs or gateways in an existing brownfield site, or you have the option of deploying our edge controllers and industrial PCs on a greenfield site, depending on what specification you require. Again, the edge solution takes a very pragmatic approach of utilizing little data to better get contextual insights and unlock more value. Because the solution is so easy to configure and fast to deploy, it is a quicker path to ROI. And lastly, when you consider these small quantifiable improvements from these smaller IIoT implementations, it really does help drive acceptance and accelerate the digital transformation journey in the company. Moreover, these initial results, can help to drive the business case for other more autonomous driven operations, or even the switch over to remote operations, because you have been able to show value with these smaller exercises.
So applying this, right? Applying the PACSystems in a mining scenario. So Package IoT platform builds a foundation to support both the operational technology, so your OT guys, and the information technology, your IT personnel. And end users can easily build and deploy applications for a wide range of users, including monitoring of energy, machine health, and productivity. Emerson's modular pre-configured development packages containerize applications to allow developers to start in a pilot environment with just a few units, right? And then we can scale from there quickly, and we can journey with you on that. Without expensive network and server infrastructure, or worrying about inconsistencies among operating environments. Again, it's all based on our CPL 410 or our industrial PC portfolio. And what it offers, administration for IoT devices. So we have a graphical user interface for centrally configuring edge devices, and a built-in tooling for device performance analysis and troubleshooting. Secure managed IoT platform. So version updates, validated, delivered by Emerson once they're available. Cyber tested with Achilles certification devices, very important. And then again, this whole concept of open connectivity to meet your needs. Connect to most plant equipment and severe industrial, serve that data up to other IoT applications via our standard protocols that we know in the industry. So OPC UA, MQTT, and REST calls. We do incorporate to other systems, or we have the capability of DMP3, and we can do hard devices and hard pass-through. So that's also something to note.
Okay, so the next thing that we need to consider from a mining perspective is this idea of high availability. For the most part, mining has always adopted an approach where spares should be readily available. But as cost pressures are rising, mining can scarcely afford any unplanned downtime. So it's crucial for the industry to rethink its philosophy around maintenance as well. And again, when you factor in remote nature of sites and personnel allocation, maintenance planning can become a very complex issue to manage on site as well. And so we need a better and more effective way to do that. For many years, high availability itself was difficult to deploy on a large scale and really quite expensive for the use on smaller systems. So the required return on investment dictated that high availability should really just be applied to the most critical parts of the process and critical machines as well. And this typically meant that where you would have DCS systems, that's where high availability was more commonly implemented. But for smaller systems and machines where PLCs were the norm, high availability was sometimes too complex and too expensive to implement from both the parts and a labor perspective. Now, this is where Emerson has changed that equation for these smaller systems and machines with a wide variety of complementary technologies that are easily implemented and maintained to provide high availability. So you can deploy this at scale to unlock smarter and more secure operations and deliver on that high availability requirement that you may need. And this is again where mining needs to rethink this to achieve optimal uptime. It needs to move away from this idea of a central control scenario where that could just be the single point of failure. And then even from the idea of having a backup controller in stock, which is really just a reactive maintenance philosophy today. So high availability should really be something that you think about in a modern proactive maintenance philosophy. And this is again where Emerson is making it possible to implement this in systems quite easily and rapidly.
Our high availability architecture, right? So our modern PLCs or PACs, as we like to call them, programmable automation controllers, and our edge controllers, such as the Emerson's PACSystem RX3i controller, provide a solution so two controllers can be supported at the same time, running in parallel, fully synchronized and locked together in real time with access to the same I/O. This way, the controller ceases to be a single point of failure, since a fault in the primary controller can cause a transfer to the secondary in a matter of milliseconds. Emerson accomplishes this through a patented reflective technology, RMX module, which completely transfers an image of the necessary memory from a primary or active PLC or PAC to the secondary standby or backup controller every single scan, right? So the two controllers communicate with each other over this dedicated link designed to support a lockstep synchronization, scan for scan, so the backup always has the same data set as the primary. And this can permit failovers in a single PLC scan as fast as 5 milliseconds, depending on the configuration. But the main consideration is that the failover time is deterministic and not variable due to other conditions. Now, unlike competitive high availability solutions that require the two controllers to be in the same hardware mode, have identical software and firmware loads, Emerson's high availability solutions are designed to continue seamless operations even with different software or different firmware versions installed on the pair of controllers. So some automation applications demand the highest level of control logic performance, with others need good connectivity to high-level systems. Emerson offers PLCs and edge control solutions to meet all needs. Both support Profinet fault-tolerant IO-ring communication networks to ensure the best availability of IO nodes.
So when we factor in both this high availability concept and edge devices, this is typically the architecture we would propose for mining. As you can see, for each of the systems, so the extraction, mineral processing, mine infrastructure, and rail and ship loading, they each have their own Profinet ring, and that's able to interface with various instruments and OEM supplied equipment. Each of these subsystems is managed by a set of redundant task management PLCs, which are essentially monitoring and scheduling each of these subsystems and allowing them to operate independently. So in the event of a downtime event, these PLCs will allow each of the subsystems to be stopped safely if the entire site needs to be brought offline. And in this way, you can see that it delivers on the flexibility and high availability component to reduce downtime or eliminate a single point of failure. We're also showing this remote operations center, which again, I've said is becoming increasingly important for the industry. And I've tried to show a little bit of versatility in this architecture. So if we're talking about a brownfield customer site that's looking to integrate edge solutions, this could be third-party PLCs, but we could still layer this with IPCs and edge gateways that will aggregate the key data and transmit this for analysis and decision making. And again, the edge devices here optimize and reduce the volume of data being sent up to the cloud. And again, this would typically be excessive when you consider that most of this data is time series data. For a greenfield site, we could recommend using our edge controller, the CPL410, in redundant configuration, and this will deliver real-time improvements at the machine or process level, depending on how you want to architect the system. But again, it puts you in the driving seat to start deploying those optimization applications from day one of your operation.
So single toolchain concept, reducing energy engineering complexity. A crucial aspect of designing and managing is the configuration aspect. We often underestimate the complexity that this can add to design and the impact of deployment of such a project. The great thing with Emerson's portfolio is the single toolchain concept. Single toolchain, right? The entire automation portfolio is programmed, configured, and maintained by a single PAC machine edition license, one license, right? One piece of software. A fully integrated development system, allowing building of HMI panels and control logic in one integrated development environment. Under the hardware configuration, we can configure all of our controllers, our HMIs, our VFDs, server drives, and Profinet Ethernet switches, I/O, as well as IO-Link sensors. We are fully IEC 61131 compliant, so structured text, relay ladder diagrams, function block diagrams, native C blocks we support, and over 140 blocks with another additional 30 advanced blocks that can basically boost productivity through reusable modules, combining the best of traditional programming and graphics applications. Again, users can build applications rapidly with user-defined function blocks, user-defined types, and control modules. These reusable building blocks, in essence, allow the development of control logic to be done in an object-oriented fashion. And then we've got the built-in diagnostics, which allows user to display controller status and timestamp data and faults if need be. So how the single toolchain works is we create variables, we add variables to our PAC machine edition, and those variables then are basically accessible throughout the entire program environment. Within one project, we can have multiple controllers and maybe some HMIs associated with that, and those variables then are able to be used within those different projects. So if we've got on a local skid or a local conveyor or whatever we may imagine, and we've got a control system there, and we need a local HMI for the operator to control that, those variables or those inputs basically from the field and outputs that the PLC sees are directly available for the HMI. And so it just very quickly simplifies the entire implementing of a project. We will now present a few conceptual edge use cases. We are in active discussions with existing customers to implement these solutions. So these are based on real data and projected benefits. This is the particular customer where a mining customer wanted to upgrade an old crusher on site. It proved difficult to maintain as it had no online monitoring or diagnostics systems. It was very remote, and the planning for maintenance and procuring spares was a challenge due to very long lead times on certain parts. The customer decided to upgrade this crusher in-house, and we're looking to implement an online monitoring system for vibration monitoring on its gearboxes and other crucial pieces of equipment. So in this solution, the customer opted for Emerson's edge controller, the CPL410, to do the vibration analysis. Since they were dealing with a high volume of time series data, it would be costly to send this volume of data to the cloud and to the remote operating center. So instead what they did, and what we assisted them with partially, was to use this edge controller, embed the vibration algorithm, and this was doing the computation of several key vibration metrics on the edge. This data was then sent to the remote operations center for analysis by SME. The feedback of the vibration data would then serve as an early warning system and help plan for the shutdowns more effectively. In addition, the customer was able to order those long lead items and spares as required and coordinate that with the maintenance personnel on site for more effective planning and scheduling. And this shifted their entire maintenance strategy to a proactive one for this asset. And this is, in our eyes, a great example where a customer is very experienced in implementing a small IoT solution themselves, but in much of the same way, an OEM that doesn't have a monitoring solution could consolidate several equipment KPIs and generate overall equipment effectiveness, or OEE. This could give them a better visibility into their fleet of equipment at various customers, allowing them to troubleshoot remotely and meet the requirements of several levels of their service level agreements. When it comes to the overall equipment effectiveness, mining is in some aspects well behind other industries that have somewhat similar workflows, right? So if we consider oil and gas or manufacturing, and they've been doing this for some time, and this becomes a huge value add for the customer and a lot of our OEM customers.
Okay, so aside from the great example we had on the online vibration monitoring, energy consumption of mining assets is really another significant part of the overall operating costs as well. So again, when you factor in remoteness of the operations, mine operators themselves have to now build and manage their own power infrastructure. So this is an example of a customer who's very forward thinking and has started to generate green hydrogen from solar on their site. And they're using this in conjunction with a diesel generator system and battery storage. The customer wants to get a better handle on site-wide energy consumption and really wants to start optimizing and reducing its diesel consumption. And then it's keen to also start looking actively on how it can curb those excessive emissions as well. So this solution is still in concept phase. It's part of a larger solution. The crux of it is a machine learning algorithm, which is going to be monitoring the energy consumption site-wide to identify the optimal scenarios. So with that, it has to monitor weather conditions under seasonal changes, particularly for the solar, because that impacts its ability to produce green hydrogen on site. The ideal scenario, again, for the customer here would be to get to a point where it produces as much green hydrogen on site and then assess daily whether it needs to switch on diesel generators only when it's required. So this customer is still going through the journey of installing additional meters and sensors to start the pilot. But based on their initial analysis, factoring in this kind of solution, the energy savings could be up to 1 million per site per year. So we're excited to help this customer to start deploying this pilot, and we're looking forward to that initial data coming back to confirm that this analysis of savings is 100%. And then lastly, this is another great example of single toolchain in action. I know we've spoken a lot about this, and this is where it really helps customers manage sites with ease. So this is a case of a global mining and building materials company that's growing rapidly through acquisition and expansion. It's often acquiring several mine sites on a yearly basis. And as it would happen that most of these sites are running on very different automation platforms, disparate PLCs, and this presents a huge complexity for them to manage. So, one of the big concerns they have at this point in time is that personnel are not trained on the wide variety of automation platforms. So making sure that their operations run continuously, managing upgrades, and even scheduling maintenance has become very, very difficult. And then when you add in the complexity of managing critical spares for multiple vendors, it becomes increasingly challenging for this customer to manage all of these different sites as well. So to streamline operations, the company chose to standardize on Emerson's PLCs, in part because of our ruggedness and the quality of the hardware, and then also due to the fact that we had a unique programming environment, which is PACSystems Edition. Each of these new sites had to be migrated to Emerson hardware, and they based this on Profinet to overcome the challenges of the legacy installed systems. And this also allowed them to integrate a variety of vendor products with the PACSystem RX3i control architecture. And again, because we have the single integrated environment on PME, our PACSystems Edition, it allowed them to configure and maintain control applications. And this has greatly reduced the complexity and engineering hours for migration and implementation. And what it's ultimately meant for this customer is that their total cost of ownership has reduced drastically. And with this tool in place and the maintenance team well versed in using the PME tool, they've been able to complete on average 15 of these migrations on a yearly basis as well. So this is a great example of a customer that's using this tool, and it is giving them a great way to reduce their total cost of ownership and manage all of these sites simultaneously. I think in summary, I hope we've been able to show you that putting edge at the center of your digital transformation journey in mining will really be crucial to unlock more value. Again, embedding edge and combining it with high availability is really going to be key to future-proofing your automation investment. And it's going to be that foundational layer for IIoT deployments. So again, with the single toolchain piece that helps to configure and deploy. And this is going to really put the customer in a comfortable mindset to undertake some of these smaller experiments, become more comfortable with the software platform, and then start scaling that for more optimization exercises and accelerate that entire digital transformation journey. Thank you for your time, and I think we're at time and ready to start taking some questions.
Yes, thank you very much, Tishan and Dieter, for that interesting presentation. It is now time to begin our Q&A. We already have a number of questions that have been sent in, but there is still time to send in more. As a quick reminder, if you are using a mobile device, you can access the question box by tapping the icon at the bottom of your screen. And for those of you using a desktop or laptop, just click the orange arrow on the right of your screen to open up the user interface and type your question in the box. As I mentioned earlier, we will try and get through as many questions as we can, but any that we don't cover, we will pass them on to the team at Emerson, who will get back to you at a later date. Now, with all that said, let's get started with the questions. So firstly, a member of our audience has asked, what are the main benefits of having a single box design for the Edge controller?
Okay, I can get that one. Yeah, so single box really just means reduced panel space, reduced power supply wiring, and no external network connection. So this is again where the CPL 410 is a great example. It uses an internal virtual Ethernet channel with OPC UA as the protocol.
Fantastic. Our next question I've got here asks, can the PACEdge stack or Linux partition write to the controller?
Yeah, so I'll take that one. Yes, it can. So the subject of cybersecurity protocols such as password and certificate configuration has been taken all into consideration with a virtual NIC or virtual LAN port within the actual device. So the controller may have additional controls such as read-write, read-only capability, but within OPC, we've got the certificates and we are able to pass information back to the controller. So if you think about it, two halves of a brain, one is deterministic, continuously running the process, and the other one is we can influence that process, right? So we can read data from the process, gain insights or change certain aspects of that process and write back to the processor or the controller, which then can update the process to perform better.
Thank you, Dieter. Another question here. What day-to-day support does Emerson provide to users when they are implementing its technologies?
So we've got a great services team that are online 24/7. And they can assist you if there is some sort of fault that you're having on a system or a journey, and we would really like to partner with our customers and see how we can solve these things together, right? So if it is a data journey and they need to be able to understand if they need to collect more data or not necessarily less data, but just more data, and if they should analyze that data on the edge, which we strongly suggest, we will definitely journey with that. We've got a great services team worldwide that can assist.
Perfect, that's a great answer. A similar question here, which asks about training. They ask, how easy is it to introduce these systems into existing frameworks? Is training provided?
Yes, so we do have a great training team, and we can do this in two ways. We've got an online training platform that you can subscribe to and access via Emerson's website, and that gives you the software, our PACSystems machine edition software, and introduces that to you. The languages as such are cross industry and knowledge, right? So it's really just getting to know the software, or we can do an on-site training, right? So if the crowd of people are big enough, again, that's just a services call, and the training guys will be able to come out on site and give you a hands-on training if the classroom size is right.
Additionally, I just want to add, so I mean, we have an extensive channel partner network as well, and if you're looking to execute this IIoT solution, you would either have support from the channel partner in the region or Emerson directly as well. So there's enough and ample coverage so that we can be able to support you with the training that's required.
Brilliant, thank you both for that answer. Another question I have here asks, what sort of analytics can be performed?
Okay, I think I can get that one. So there's a lot of possibilities, and I think we try to cover some of the interesting ones that we're doing with existing customers. But as an example, you could monitor machine runtime or start-stop cycles to determine when routine maintenance is due. You could measure machine usage and output, and again, that ties into this overall equipment effectiveness piece. You could collect KPI data and dashboard those so that users that need the data have it accessible. There's also room to do some implementation of simple digital twin to make sure that the machine is operating as intended and that it's not compromising the entire process itself. So there's also the possibility of implementing machine learning for advanced control to make sure that the process or the machine is operating at its most effective level as well. So it can be as simple or as complex. It just really depends on what you want to achieve with the platform. Like I said, I think we try to cover kind of a simplistic solution with the vibration monitoring, which illustrates how easy that was to deploy, and then something more complex like the energy management system, which requires a lot more time to train the algorithm as well. But the point is, the IoT solution that we're providing can scale to both of those scenarios.
Excellent, thank you, Tishan. Thank you both for those answers so far. Just a quick pre-warning that we are now coming towards the end of the webinar, but we do have time for a few more questions, so please keep sending them in via the question box. We have a question, a very specific question here from Joyanta. Apologies if I'm pronouncing your name wrong. They ask, do you have any footprint in Indonesia?
So I'd have to check and come back to you offline. Look, we've got some extensive install base across Asia, particularly Australia, Latin America, and other regions. Indonesia is quite a specific geography. I'd have to come back to you offline, but happy to circle back with some of the information there.
Excellent. This next listener asks, competitors offer Windows IoT. What is different about PACEdge with Linux?
Yeah, so Linux is a standardized right in the industry, and it's modern for IoT applications. Can provide a better platform for open and capability, and it supports all the open source tools that we are using, right? So Docker containers, Node-RED, MySQL, and Grafana, just to name a few, run quite easily within the Linux environment. So Linux is easy to support, it's secure, has a very small footprint, and it runs fast compared to a Windows environment. So very important.
Yeah, great. I think additionally, just from a competitive perspective, they would provide you with a blank box, and it's really up to the customer to install and configure the PLC runtime and edge window operating system. And this is where it significantly increases the amount of configuration and validation time across the several edge controllers that a site may require. So this is where, with our PACEdge 2.1, it supports so many web HMI tags, and you can install our Movicon Next on the Linux side, which gives you the flexibility to host custom drivers and integrate a proprietary and wide range of devices within the control system as well.
Perfect, thank you both. Looks like I've got another question here which asks, how can I keep my plant secure with an open source platform and cloud connectivity?
So can I take that one, Tish?
Yeah, sure, go ahead.
Yeah, so the PACSystems has an unmatched competitive in-depth or defense in-depth security strategy that includes hardware TPM, secure boot, digitally signed and encrypted firmware, and encrypted user login or user information and OEM passwords, as well as the new PAC Security Center for secure provisioning of PAC system controllers and seamlessly managing the security certificates for all devices using OPC UA, allowing secure encrypted communications between them and other OPC UA servers. This helps toward any denial of service or man in the middle kind of cyber attacks. Yeah.
That's great. Thank you very much. Tishan and Dieter, I think we seem to have run out of questions so far, but did you have any closing comments you wanted to add?
No, nothing else. I mean, looking forward to connecting with you if you have any other questions around Edge and the possibilities here in terms of analytics. So please feel free to reach out to myself or Dieter, and we're happy to get onto a phone call or chat in person. And looking forward to connecting with the audience on this topic.
Well, thank you very much, Tishan and Dieter. That's excellent. Sadly, I'm afraid that's all we have time for today, but thank you everyone for all your questions. As Tishan said, please do send over more questions offline if you do have them. Emerson will be very happy to answer them for you. And as I said, we will be passing all the questions we had today over to Emerson, so they will go into more detail if you require. On behalf of the Global Mining Review team, I would like to thank Tishan and Dieter again for an excellent presentation and Q&A. And thank you to also all of you in the audience for attending. Again, I would like to remind you all that everyone who signed up to attend this webinar will receive a copy of the full presentation via email. And while you are here, make sure to sign up for a free trial of Global Mining Review magazine by visiting globalminingreview.com. Thanks again for attending today's webinar, and enjoy the rest of your day.